Well, good afternoon.
The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. My name is James Craig. I'm a senior geologist at IEAGHG. Welcome to our second webinar on the CO2 Data Share. You may recall back in May of this year, we ran a webinar on the whole concept. This time, we are going to look at a little bit more about the functionality of this facility, and it will be your opportunity to give us some feedback and to send us questions about the functionality and what it can do. For those of you who are not familiar with IEAGHG, we're a program that's been running since 1991. We have 32 members who fund us. They include OPEC and the Coal Advisory Board. We do contribute to the strategic direction of carbon capture and storage, but we are a technically based organization, so we're not policy advocates. We assess mitigation options. Much of our focus is on R&D, including commissioned work. We track the global development of capture technologies and monitor geological storage sites and demonstration sites. And by doing so, can therefore provide our members who fund us and indeed those other wider audience with independent technical advice. As you can see, we have a broad range of country and industry sponsors who generously fund our work. So today, Greta Tanger from SINTEF is going to briefly set out the project goals. She will be followed by Odd Anderson, also from SINTEF, on the platform's functionality. And then we move on to Philip Ringrose from Equinor, and he will be facilitating feedback and suggestions that you have sent in. And lastly, I'll conclude with a brief summary. So Greta is a senior scientist at SINTEF. She specializes in multi-phase flow, also has long-standing experience in the management of multidisciplinary projects and the development of strategic research projects. Surprisingly, her areas of expertise include CO2 capture, transport and storage, linked oil and gas production, energy efficiency and energy system analysis. Greta is also the project manager for DataShare. Odd Anderson is also a researcher at SINTEF Digital. He has a background in applied mathematics and cybernetics and has a mathematical modeling research degree in CO2 storage from the University of Bergen. He's well known, has published in several international journals on this topic. He's also a key contributor to the open source MATLAB reservoir simulation toolbox and carries out support and educational activities. And finally, our final panelist is Philip Ringrose, who is a specialist in CO2 storage and petroleum geoscience at Equinor Research Center based in Trondheim. He's also the adjunct professor of CO2 storage at the Norwegian University of Science and Technology, also in Trondheim. His background is in geology. He has 2 degrees from Universities of Edinburgh and Strathclyde, and I'm sure you're well aware that he's published widely on reservoir geoscience. So with one final point I would make, as I'm sure you may well be aware, we have a big conference, GHGT 14, rapidly approaching. It's about a month away. So if you haven't already booked, now is a perfect opportunity to come to the world's leading and biggest conference on carbon capture and storage. And with that, I will now switch to Greta.
Just there.
Okay, thank you, James. I will just start a little bit. I think I lost your screen now, but
yeah, we need to share the screen, Greta.
Yeah, okay. Yeah, but I can just start while you are doing that, because I just wanted to say a little bit about the background and the goals of the project. And as
we can't see your screen.
Says it's about shaping the functionality of the CO2 Data Share platform, and that is exactly what we are doing right now. We are defining the features of a new digital platform for sharing CO2 storage data.
Excuse me, Susanne.
Yeah.
I have the slides on my screen, so if you can share my screen, then.
Okay, so this is odd. Yeah.
Mm-hmm.
Let's do this.
Yeah. Okay. That's okay. I just wanted to recap a little bit around the project very briefly. And the work in this project actually started already in 2015 in the discussions between US and Norwegian researchers. And it was realized that sharing reference data sets from CO2 project would be very useful to improve the understanding of CO2 injection and storage, and thereby making us able to reduce the costs and also minimize the uncertainties associated with CO2 storage in the subsurface. So last year we were awarded the funding from Gassnova, which is a Norwegian public funding agency in Norway, and the US Department of Energy. So that gave us the opportunity to establish a project to develop a digital platform for sharing reference data sets from CO2 storage projects. And the idea with this initiative is to reduce the barriers or the thresholds for data owners to actually share available data. That can be from industry projects, demonstration projects, pilots, and also models based on data. And also it's intended to facilitate the preparation of quality data sets. And by this, motivate data owners to actually share and then also promote the collaboration between researchers using the data. And for the data users, this initiative is intended to make it more easy to find data, to access it, and use the data sets online. And also it's important to make available information about the data that is needed for the relevant use of data in research. So we have established a CO2 Storage Data Consortium, which is now organizing this project, CO2 DataShare. And the current participants of the project is SINTEF, that is the project manager, and we have University of Illinois, and Equinor, here represented by Philip, and also IEAGHG, and the funding agencies, Gassnova and US Department of Energy. And in this picture you see on the screen now, that is an illustration of kind of how the consortium is organized. We have the project team that is guided by a steering committee with representatives from all the supporting organizations, which for now is also mainly the same organizations that will be sharing data in this first phase of the project. And then the bottom here we have a circle saying data hub provider, and this indicates that we will enter a collaboration with an external data hub provider for the platform. So we have started this project this year, 2018, and we'll work through 2020. And the motivation is clear: it's to make it easy to access quality data sets that can be presented in standard formats, and then thereby help the development of methods for CO2 storage. And then by this, make CCS a safe and cost-efficient way to reduce the CO2 emissions. Yes. And we have seen that access to common data sets is useful for research. It's useful for comparing methods, and makes it easier to reproduce research conducted by researchers all over the world. And the well-known Sleipner data sets have shown that very clearly, and we have seen that from the start of the injections in the Sleipner project in 1996, many publications have been presented in journals and conferences based on these data sets made available by Equinor, that previously was Statoil. So in this project, we have a stepwise development process. Early on, we started with discussing what data sets could be shared, and also we discussed in various meetings to understand what would be needed from data share solutions. We also conducted a small survey to understand the needs better. And currently, we are focusing on developing a user specification that showing the functionality that should be included in the data share solution. And the next step will be to develop a technical specification. And we plan to have a pilot on the air by May 2019, that is next year. So to ensure the relevance and the usability of this platform, we see that it's important to have the dialogue with users and the data providers. So that is also why we see this webinar as an opportunity to present what we have done and what we are thinking, and also to have feedbacks and questions that can guide us in the further development of this platform. So therefore, we urge you to use the opportunity to ask about everything, to suggest what you would like to see in this platform. So that is what I had planned to say for introduction, and then I will give the microphone to Odd, that will guide you through the functionality of the data platform so far.
Okay, can you hear me?
Yeah.
So as Grete said, we have been working since the last webinar basically to draft a user specification, which is kind of the basis from what I will be presenting to you here. And as was also said, this is not yet set in stone. It's a draft, and we are actively seeking input. So we are very interested to hear your questions and your feedback and suggestions to see if we should keep things the way it is, or if there are things that could be improved. So I'll just shortly get to that. Just to recap a little bit, as you can see on this slide, the intent and scope. The CO2 data share was really, this initiative really came to be from the realization that lack of access to data is one factor that impedes the research and development of CO2 storage projects. So the idea was then to basically make an international platform where we can share reference datasets from different projects around the world, and with the purpose of making making it easy to share, find, access, and use data, and also to promote collaboration between, among researchers and industry and data providers. So this is a little bit the goals that we want to achieve with this platform. little bit about the intended benefits and the different stakeholders. For the data provider, the problems with sharing data, as we have learned, is that it has to do with having data properly organized, knowing where it could be published, sorting out licenses, and also the time and costs involved. So what we hope to make easier with the CO2 data share solution is to promote good data management planning, basically be aware of the value of the data throughout the whole project phase. Also to provide a clear path and assistance in preparing and documenting data to be published on the platform, and to make data visible and provide a unified data hosting solution. For the data user, it might be hard to get data, first of all, because the user might not know about the existence of the data, or it's hard to find it. Or if you get in touch with the data provider, it might be a very long process before the data provider is actually able to send data on an ad hoc basis. And then there are the problems of being able to have to read the data or have the right software, and what you can use the data for, what rights you have to use it. And again, what we hope to do with CO2 Data Share is to make data discoverable and well documented, to make clear the rights of use associated with each data set, and make it easy to download and to know what software to use. We can also add society at large as a stakeholder here. There has been this widespread impression among researchers that there is somewhat of a reproducibility crisis in sciences, where lack of transparency makes it hard to really to check or to verify that what has been published in research publications can be reproduced. So part of the remedy is here the sharing of code and input data, and that should be considered in many people's view just as important as the actual publishing of research papers. There was a set of foundational principles of scientific data sharing that came out, and that has been put forward recently, that is called FAIR, F-A-I-R, which stands for findability, accessibility, interoperability, and reproducibility. And this is something that we also hope to support with this initiative. So now I'll go a little bit through the what is in the user specification. Let's see. First of all, what are reference datasets? Because we are talking about sharing reference datasets on this online platform. So our definition of data, of the research data, is information that has been collected, measured, or created for the purpose of analysis or interpretation. And then that can include measured or observed data, data generated from the transformation of other data, technical data, or modeling data. And then if this is our definition of data, then a data set will be a collection of data that belongs together, typically by relating to the same storage project. And it can be small, or it can be very, very large, such as is the case, for instance, for seismic data. Also, when we talk about one data set, that could mean that there is only one type of data in it, or it could be that there are several types of data of different types in it. And that is what we mean by homogeneous or heterogeneous data sets. So in this portal that we are working on, we will make it so that datasets can be downloaded in bulk or split up in several archives, which might represent different components of the dataset, and make it easier to download so that you can avoid downloading, for instance, seismic data when you only want some simple Excel tables. Again, this distinction between homogeneous and heterogeneous datasets, two examples. The 2010 Sleipner benchmark model that was issued by Equinor, or then Statoil, has been the basis for many research papers in the past. It describes it basically provides a reservoir model of the Sleipner CO2 storage site in the North Sea. This is a single grid with associated simulation parameters. So that is an example of a homogeneous data set. Whereas there is a new Sleipner benchmark dataset that is scheduled to be published on the CO2 Data Storage Data Share portal at launch. This dataset is much larger, and it contains a lot more information, including well positions and logs, interpreted seismic data, a velocity model, and injected CO2 volumes. So this is what we mean by heterogeneous dataset. And again, when we talk about a reference dataset, by that we mean we are talking about a dataset that has been recognized to be of high quality and relevance for a larger community of researchers. And by high quality here, we mean that the data has been checked for errors and have gone through some quality assurance process. It has been prepared, documented properly, and that licenses and terms of use have been clearly explained. And this should be the preconditions for publishing a dataset on the CO2 DataShare portal. So again, for a reference dataset that you can find on CO2 DataShare, you would know that this dataset has been checked for errors, omissions, and so on. It has a digital object identifier that makes it uniquely identifiable and can also be used to cite the dataset so that you can make clear exactly what data you're building your research on. All the relevant metadata has been assigned, so there is data that explains the contents of the dataset and also allows for machine processing and retrieval. The licenses and terms of use and access rights have been clarified. There might be relevant associated publications that have been identified and linked to the dataset. And a landing page has been prepared. And by landing page, I will get back to that a little later in the presentation, but that is a dedicated web page to give an overview and explain a particular dataset. So it's intended to be a way of discovering the data and to help browse the site. So there are many kinds of data that can go into the portal. The scope is really anything that has been collected or used or associated with a CO2 storage project, and that meets the criteria of reference dataset so that it has a relevance for a larger community. And this could be processed seismic data, well logs, and so on. You see this list here, also including results from computer simulations, surface deformation, GIS data, and so on. So many different types of data that could go in there. So how does data get into the portal? Contrary to many other data sharing initiatives that can be found online, we do not foresee, at least for the time being, that potential data providers can go ahead and just upload datasets themselves. There is a process involved where when a dataset has been identified by both the consortium and the data provider as being something that should be included, then there will be a dialogue basically between CO2 DataShare and the data provider, and a process where the dataset is prepared to meet these criteria that was mentioned. So that is much of this is relates to licenses and also to documentation, and much of this is of course things that has to be primarily done by the data provider, but with support and feedback from the consortium. And then, in order to prepare this landing page, the data provider, of course, has to provide the information itself, and CO2 DataShare can help assemble the information into a web page that that best presents the dataset. And then the final step, which is the online publication, is something that can be done by CO2 DataShare after a green light has been given from the data provider. The data preparation task, which is basically the specifics of this process, involves many steps, including the choice of data to include, to check for errors, to choose the right data formats. That means that, I mean, sometimes data has to be on a particular format, but if there is a choice between different formats, then we should preferably go for standards that are open, or at least as easy to use as possible for a larger audience. If there are software scripts that could be useful, decisions have to be made on what, if anything, should be included with the data. The files need to be structured in a logical way. All the metadata has to be prepared. If there are articles that are useful to issue along with the data, or technical reports, then that should be included. And then there is this, we have to make sure that the proper licenses are used, and whether the data should be hosted by CO2 DataShare or by the data provider itself. In any case, the data would be should be downloadable by the portal, but the actual physical storage location might differ depending on the dataset. A little bit about the access levels. We want data to be as open as possible. So preferably there should be an open license, and the data should be freely downloadable. We should consider that to be kind of the default, but we are also flexible in this respect when the data provider has to use different licensing options. So it's possible to have other licenses, and it's also possible that data are not openly downloadable, but that a potential interested user will have to seek permission or to be in dialogue with the data provider in order to get the data. But preferably the data should be freely downloadable. It's also possible to consider an embargo period, so that the data is uploaded and the metadata and information about the data can be searched and browsed, but the data itself will not be directly released until a specified later date. Metadata, which is data about the data, can be considered to be in several forms. On a very high level, we can consider the web page and the textual documentation and accompanying articles to be a form of metadata, since it's something that explains the dataset. There is also formal metadata, which are kind of structured information about the data, and that is provided by filling out specific forms. And this allows, for instance, more efficient searches and also machine processing of the data. There are general formal metadata, which are metadata that are relevant for more or less all datasets, regardless of type. Such data is, for instance, the title of the dataset, the rights holder, the license, the subject, and so on. But then there are also metadata that goes with specific types of data. for instance, seismic data will need to have a different type of metadata than a well log. An example here is from this 2019 Sleipner reference dataset that I mentioned a few slides back. So this is just a table that describes different seismic post-stack cubes. The leftmost column shows the vintage, which is basically the year that the seismic data was collected. And then there is another column explaining the processing year, because each seismic collection has been processed multiple times as new seismic data has been measured in later years, because they are processed together. And then there are distinctions between full fold, near fold, mid fold, and far fold, which are basically different spatial parts related to which receivers were used when gathering the seismic information. So the point here is just that metadata such as this is only relevant for seismic post-stack cubes, and other types of data will need different metadata. So we have to make this distinction between general and data-specific metadata. But for a reference dataset, which can be of any type, we then need to we need to make some kind of classification so that we know what kind of metadata should be associated with the dataset. A dataset classification further allows the user to search for specific types of data, such as simulation models or laboratory data and so on. So we propose to introduce a simple classification that helps specify what kind of data each component of a dataset belongs to, so that we can annotate it with the proper metadata and also make it easier to find for a user looking for a specific type of data. And this classification is open to revision, but it's a first suggestion. Moving back one slide, just to say a little bit about a last thing about the formal metadata. They are intended to be structured according to the Dublin Core Metadata Initiative, which is a well-established standard for metadata. And the particular data schema to describe datasets will have to evolve over time depending on the data portal contents, because it's really not so easy to determine in advance everything that might be relevant without really knowing what data we will actually, at least in the beginning, have available in the portal. But the idea is that this formal metadata should support identification of datasets belonging to distinct categories. Again, that is by using the classification. That key practical information such as ownership, coverage, rights of use, and so on can be immediately identified. That you can search datasets using tags and keywords, and identify the main assumptions, sources, and intended uses for a given dataset, and the storage format, and what software can be used to read it. So for the user, the way to use the portal is to access it on the internet, of course. The portal will be designed as a modified or a derived solution from the well-established open source CCAN data sharing solution. So the idea is that there should be a unified interface to all the published datasets, whether they are stored actually on the CO2 DataShare server or at a specific dataset provider. All the metadata and the landing pages could be searched and browsed freely from the portal. And if you want to access the data again, then for open data, you can just download it directly or go in and download the component of the data that you want. If the data is restricted, there will be an option to get in touch with the data provider and negotiate how data could be obtained. The technical solution is still under development. As Grete mentioned, we are now working on the technical specification, and the implementation will take place this winter. And we hope that the portal will be online and available. It's scheduled to be online sometime late spring 2019. Since we are talking about the portal, it's worth talking a little bit more about the landing page, which is the presentational page associated with a specific datasets. So each dataset should have a landing page. It can be very extensive, or it can be relatively brief, depending on the need. Here I'll show an example of an existing something similar from a different project. The full page is shown on the left column, and then I have magnified the text and spread it across 2 columns so that you can see a little bit more what the structure looks like. So basically, this is a page that documents a simulation model. So it gives some graphics, some links, some key data, and explains some assumptions and some facts that are good to know if you want to use it. And there is also a link to related publications and so on. So this is an example of what we foresee, but the landing page can also be simpler for very small data sets, or even more. It can include other types of information like tables and graphs and so on as well. So again, as I mentioned, the first version of the data portal is expected to be online by next summer. The initial datasets are likely to include the old and new Sleipner benchmark that I mentioned before. Then some selected data from the US Decatur project, the Johansen formation in Norway, and possibly others. And the intention is that this will grow over time as we collaborate with data providers to have new datasets prepared and published on the portal. And we are also thinking about possible future extensions in terms of portal functionality. This could include a discussion forum, online visualization tools for certain kinds of data, or a database over publications that have been published based on the datasets. And again, this is at the outset, it's a 3-year project, but as we foresee this to be a long-term solution, then there is we are looking into ways to figure out how to fund a continuous operation into the future. So I will leave it there, and I'll end on this last slide, and I will give the word back to, or I'll give the word to Philip. So
sure. Thanks, Odd. Does everybody hear me now?
Yeah.
Yeah. So thank you, Odd, for explaining what I thought might be a simple process. And I think data sharing in this context is we have to be precise and we have to have quality. So I think, you know, what you've explained is very useful. But a key part of this webinar now is to get feedback from potential users as to questions they have and, you know, things that maybe we haven't thought about. So what I'm showing on the screen here is a mind map of some of the questions that we've thought of already or have just been sent in just before this webinar. And I'll briefly explain that and then ask listeners on this webinar to come with further comments or questions. And I think the way that'll work is that James and Suzanne at the IEA Greenhouse Gas will field those questions to me and others. So just to explain the mind map, you know, there are two basic issues. What does the data provider want and have concerns about? And that's mainly about maintaining high quality, facilitating technology development, and building confidence in CCS. Assuming that most of the people on the call are potential users rather than data providers, we'll spend more time on the user interests. But the sort of questions we've had already are, you know, will it be easy to get the data, and what kind of data will we have? And as Odd explained, well, we're working hard on that, but we imagine we'll have seismic data, model data, well data. We had recent questions on whether we would include CO2 EOR projects, and we're open to all these suggestions. Another interesting question was, could these data sets be grouped in a way to facilitate international comparison studies? And I think that's a very interesting question, which I could say yes, but we'd have to work out the details too. And then finally, I put down interest in novel and new technologies and data sets. We have a bit of a digital revolution going on around our world. So we're certainly open to novel data sets, but I think mainly we're going to be focused on high quality digital data sets. So that's the starter for the discussion. So I wonder if there are further comments or questions.
Yeah, Philip, we've just seen a question. Somebody has asked whether these data sets might be open to the public, and if so, does that open the possibility of negative interpretations that may influence adversely or otherwise the public's perception of CCS?
Yes, good question. As I think we explained just today, is that some of the data sets will definitely be publicly accessible, but it may be that others require some kind of agreement prior to sharing the data set. So if you take the example of the Sleipner data set we shared 5 years ago, users, it was publicly accessible, but users had to sign an agreement, a very simple online agreement, to say that they would respect the data and notify the owner of the data of any publication. Obviously, we can't police that, but there will be a requirement on the user to, in some way, honor and respect the data. And the other thing is that we're very focused on ensuring quality. So I don't think we can absolutely stop negative interest, but or negative reactions. But I think what we will do is try and ensure high quality and that the data sets are understood. But that question, I think, identifies a concern that the data providers might have.
Right. Another question. I'm not sure who this is, but somebody has pointed out that the IEDA already has data links to publications. Now, I'm not quite sure what that is, but you might be aware of it. And how does it compare with what's being proposed here?
One of the things we've definitely spent a lot of time on is what we don't include in this, because if you just think of the world of CO2 greenhouse gas management, there are numerous initiatives, national archives, you name it. There are many initiatives. So we recognize lots of other activities, including, for example, you can Google publications to find out who's published on Sleipner or something like that. So our intention is to focus on what we call reference data sets. So we're going to focus on CO2 storage projects initially and high quality reference data sets that we think will be useful for technology development. But I think if users alert us to other useful facilities, such as that one, IEAGHG, I don't know it, but we could probably include links, for example, on our metadata pages, saying users can go to these locations to find other information.
I think.
Would you agree, Odd, that we can put links to other data sources?
Yes, absolutely. Links to other data sources and also links to software that could be used to read and interpret the data if there are open software to do that.
Good idea. Was there another question, James?
Yeah, another question is what software will be used for modeling? And then we've got CMG. I'm not quite sure what that is.
That's the question.
That's the question.
Yeah, well, Odd Anderson knows a lot about this topic, but there are many commercial simulators that you'd have to pay money for to access, including the CMG simulator. And users may well have access to their own commercial software, and that's absolutely fine. But we're emphasizing that users who don't have access to software could use open source software. And Odd mentioned the MRST platform as one example. But so we imagine that we will not only share data, but we will have pointers to open source software.
Okay.
So that if you're a user that doesn't have access to commercial data, to commercial packages, there is still something you can use. And this, in many ways, is part of the trend of technology at the moment. There's more and more information is becoming open.
But this is also an issue to consider when. I mean, this is also touches on this data management planning and also the process of uploading data and preparing a reference data set. That if there are options available that you could convert your data into to make it easier to read, then that should also be strongly considered. So of course, with the open standards being the best, but of course that is not always possible.
Yeah. Yeah, these are very good questions.
Well, another thought that occurred to me, and Odd alluded to it, is the whole question of transparency, and particularly maybe when there are contentious issues that arise, that we have here a potential forum for reviewing data sets where people have drawn conclusions. And this is really more of a comment than a question, but hopefully this could be a useful platform for detailed appraisal of, say, data interpretations and then referring to the original data, so that some of the potential confusion that can occur can be open to the public. I mean, or rather to the wider scientific community. Does that sound like something that is feasible?
You know, James, I've always said that this is a little bit of our experience in Statoil and Equinor with operating CO2 storage projects. Is that there's always someone out there who wants to take an oversimplistic interpretation and come to a very negative conclusion.
Right.
But our experience is the best rebuttal to those very simplistic interpretations is to point to very advanced, high-quality interpretations. not necessarily our own that are out in the public domain, because it's a bit like, you know, if you hear a rumor that is unsubstantiated, you quickly reject it, especially if you get good information from a reliable source.
Yeah.
So I would hope that what we end up doing is promoting, you know, globally, a whole bunch of good interpretations of reliable data, so that, you know, it generates positivity rather than negativity. But
yes,
that's a very big hope.
Yeah, well, I would hope so as well. I think that's a real exciting possibility that this whole facility can offer. There's another sort of general comment that's come in, that if people have downloaded data and then possibly added to it, that they could then feed back the data to this facility. I'm assuming that this is a sort of, there will be an opportunity for iteration between researchers. Is that the intention?
Yeah, I think that is part of it. We've thought very much that, for example, users that publish interesting interpretations of data, we'd like to have a link to all the published analysis of data sets that are shared in CO2 DataShare. So that's a very basic way of making sure that users that bring added value are connected back to the data set. But maybe we should also consider the idea that if a particular user comes with a revolutionary new understanding, that is somehow fed formally back into the data set.
Yeah.
We haven't thought about that.
Well, there is this limitation that if we have given a digital object identifier, that data should not be changed later, because references to that data should really be referenced to the data that was used at the time.
Right.
So what is possible would be to make a new revision of data and assign a new object identifier. That is something that is possible.
Yeah, good point. So there has to be traceability in earlier generations of data.
Exactly.
Yeah.
And the question about the Sleipner benchmark data set, which presumably will really become part of the launch next year. I'm assuming that a lot of this material is in different places at the moment, or maybe it hasn't even been processed yet. But will there be new material in there, as well as the sort of work that's been done over the last decade or so?
Yeah, there'll definitely be new material. The owners of the data, the Sleipner production license, they have agreed to share the latest seismic survey, the 2010 seismic survey, so that will be included. But as Odd was pointing out, it's always derived data that's in here. So when we say we will share the 2010 seismic survey, it means that we will share processed data sets for a particular time interval that are useful for interpretation.
Yeah.
And then, of course, all data sets have uncertainties and errors associated with them. So, for example, we do not know exactly where the top of the storage horizon is. We have a certain error over that surface.
Yeah.
And we would try and be clear in the metadata that there are errors associated with the data or uncertainties associated with the data.
And that's very important in this and any other work, that that is made clear, because as you alluded to earlier on, you know, sometimes oversimplistic or interpretations are made because people are not careful enough with the use of data that's available to them. There should always be that caveat. You know, again, it's a sort of point for maybe a future discussion forum.
Yeah, and I really appreciate that Odd is making this point about the general challenge in modern day science is to encourage reproducibility and quality of data. So I think if we set some standard data set out there with a certain quality, and it's referred back to, then we actually provoke further quality.
Yeah.
And for example, if a user wants to simulate CO2 storage in a cube with homogeneous properties, I don't find that very interesting.
No, it's not very realistic either.
But if a user simulates a CO2 storage process with some novel understanding in a complex rock system, then very interesting results emerge.
Yes. Good. I think that really brings us to a very nice conclusion point. I think this is a very exciting facility. It has huge potential, and a point you just raised is this whole question of scientific transparency, which is of course not unique to CCS, but is creeping up the agenda in various places. I certainly think good reference data sets are another important facility. We tend to think in perhaps the North American and Norwegian context and a few other places that we're well advanced, but we need to remember that CCS is of growing importance across the world, and that's why having these good data sets and this global interaction is so important. And I think this is going to be a very exciting time. So we look forward to the launch. No doubt there will be plenty of additional publicity at the time. Please remember to everybody listening that if you are going to GHGT 14, I'm sure, well, I will certainly be there. There will be plenty of opportunity for discussion. And before we go, I'd just like to thank Greta, Odd, Philip, and indeed Suzanne, who's with me here, who's pressed all the buttons and made everything happen. And with that, I will sign us off, and we look forward to seeing this in operation.
Yeah, and we will of course post this on YouTube as soon as it's finished downloading and we're able to upload it on the system for you. Okay.
Okay.
Okay. Thank you.
Everyone.
Thank you.
Good. Thank you.